9702 October November 2017 paper 2 variant 3 topic momentum question number 3a state the principle of conservation of momentum. The total momentum before and after collision is always conserved in the closed system. Part B. Ball A moves with the speed of v along a horizontal frictionless surface towards the stationary ball B. As shown in the figure, you see the ball A is moving towards ball B, which is stationary. Ball B A has the speed of v and mass 4 kilogram. Ball B has the mass of 12 kilogram. Collide, and after collision with the horizontal, ball A makes an angle of theta and ball B makes an angle of 30 degree downward, right? And having the speed of ball A is 6 meter per second and ball B having the speed of 3.5 meter per second. Option A, part 1. By considering the components of momentum at right angles to the direction of the initial path of ball A, calculate theta. So I have already resolved it because before momentum there is in one direction, but after it has the two dimensions. So we are going to resolve the ball A with its horizontal and vertical component, and ball B with its vertical speed, of course, its horizontal and vertical component, right? So ball A will be having a horizontal component is 4 in times 6 cos theta, and ball B is 12 3.5 cos theta. Both are in the right direction, right? But the vertical component, we have 4 times 6 sin 30 sin theta upward, and ball B 12 into 3.5 sin 30 degree downward. So which is by comparison it will be minus, right? So by viewing this situation, we clearly understood that it is easy to resolve vertical component first, because the vertical component has only unknown value, which is so 0 equals 4 times 6 sine theta minus 12 in point times 3.5 sine 30. So 24 sine 30 after resolving blah blah blah, which is equals to 61 degree, right? So theta is 61. Now the second part, next part 2, use your answer to show the initial speed v of the ball A is 12 meter per second. So we will consider horizontal component. So horizontal component has 4v and stationary 0 equals like we said, the total momentum before and after collision is same. So before collision, horizontal 4v plus 0 equals 4 times 6 cos 61 plus 12 0.35 cos 30, right? Cos 30. So 4v equals 11.64 plus 336.7. We will get v equals 48.012 over 4, which is 12 meter per second, right? So the calculation is very simple. Part B, by the calculation of kinetic energy is stated and explained with their collision. With the collision is elastic or inelastic. We know this is the case of coalesces, because initially it is one body is in the rest, right? And this is partially coalesces. We don't have to write coalesces as a simple, so we should remove it, right? So we just check the kinetic energies. So kinetic energies has no direction, so that means their angle has no mean to it. So before collision, it is 1 over 2 4 in times 12 square and 0, and after collision is 1 over 2 into 4 into 6 square plus 1 over 2 12 into 3.5. So we will put the kinetic energies formula for the elastic collision, which is total kinetic energy before and after collision is conserved. So for this principle, we have uh, we have produced the kinetic energies before collision and after collision. We will see the before collision is 288 joules and after collision is 145.5, approximately 146. And their both sides are not equal. So this, in terms of kinetic energy, we say the collision is inelastic, right? It is not elastic one.